Alright, welcome everybody. So in this particular segment I'm going to look at a particular example to illustrate everything that I've covered: the phase sport rate, the solution curves, the attractors, the repellers, as well as I will actually go out and solve this particular equation, because the next segment will focus on solving these equations so I can compare and contrast. Okay, in this question, this is the differential equation that I'm dealing with, right? So the first question that you may want to ask is, hey, is this an autonomous equation? And you can see x is the independent variable and I don't see any x, so I'm good from that angle, all right? So I will be able to approach these with the fundamentals that we have covered in the last two segments, okay? So the first thing I see over here, I'm not sure you do realize that, but each term is multiplied by y, right? So I can simply simplify this a little bit further and see what happens. So I can do y times y squared minus 6y plus 8, correct? So I'm not doing anything fancy over here. If you multiply these back, you will get this equation, right? Okay, now I have myself a quadratic equation. The roots of a quadratic equation can be found like that: minus b plus minus, I recommend you memorize this, b squared minus 4ac divided by 2a, right? Like I said, I'm sure many of you did remember this, but I'm indicating. So this is a in front of it, this is b, a is 1, that's what I'm trying to say. C is 8, okay? So if I plug over here, you can see that I'm going to get 6 minus 6 is plus 6, plus minus square root of 36 minus 4 times a is 1, c is 8, so I'm going to get 32, right? 4 times 8 is 32, divided by 2a is simply 2. And if I go over here, this is going to be plus minus, that will be 4. Square root of 4 is 2, divided by 2. So root 1, from here, I will get s12 as this. The first root, doesn't matter which root number, is not important, but let's see, 6 plus 2 is 8, divided by 2 is 4. And the other one, 6 minus 2, which is 4 divided by 2 is 2. So these are my roots. If I want to write this equation, then it's going to be like this: y minus 4 times y minus 2. So far so good, right? So I was able to simplify this equation further. Okay, so why did I do this? Now I will be able to obtain my critical points or equilibrium points, and that they will be, from here you will see that the y is equal to 0, and from here you will see that y is equal to 4 and y is equal to 2 will be constant solutions of this particular differential equation. And now looking at this, let's do the same treatment that we have done for the previous question. Interval that I'm going to look at is going to start from minus infinity all the way to plus infinity, right? Alright, then existing of these will, okay, let's separate this. You can see I have a 0 here, I have a 2 here, I have a 4 here. So you can see I have one interval, second interval, third interval, and fourth interval. So let's go ahead and write this. The first interval will be from minus infinity to 0. The second interval will be from 0 to 2. The third interval will be from 2 to 4. And the fourth interval will be from 4 to plus infinity, right? Now, I need to decide, or rather determine, what will be the algebraic sign of the slope, right? I have this equation available to me. I will insert some values that fits into this criteria, these different intervals that I have, and whether I will get a positive or negative value that will determine the slope of this particular dy dx, right? All right. And also last time we have covered this, that the algebraic sign will be uniform in each interval. There will not be like plus and negative, positive. Okay. So from that, I'll pick one number just to get some idea of what's going on over here. So from here, for instance, why don't we take y is equal to minus 1, right? So let's see what happens. So it's going to be minus 1 times y minus 4 will be minus 5, right? Look here, I am plugging this number into here, minus 1, minus 1, minus 1. That's what I'm thinking. Minus 1 times minus 5, y is minus 1, this is going to be minus 3. So you can see this multiplication is going to be minus 15, right? So now this indicates that I have a negative sign at this particular interval, okay? If you wish to, which I'm not going to, you can try y is equal to minus 2, minus 3, minus 4, minus 5, whatever. You will always get a negative value here, all right? Now the next one I'm going to analyze will be this y is equal to, well, you can see what I'm going to do, right? Y is equal to 1. So then this will be 1 times 1 minus 4 is minus 3. 1 minus 2 is minus 1. So you see I get a plus sign here, right? 3 is the number, plus 3. And I'll do the same treatment, and I will obviously plug 3 over here. So that's going to be 3 times 3 minus 4 is minus 1. 3 minus 2 is plus 1. You will see that I will get myself a minus 3. So the important thing is the minus sign. So I'll get minus in that range. And last but not least, why don't we plug it in y is equal to 5? So that's going to be 5 times, let me go up, y minus 4. So 5 minus 4 is 1. And 5 minus 2 is 3. So right there I get a plus 15. So the important thing is it's plus. So now I was able to establish what will be the slope of those. Why don't we go ahead and plot the phase plot rate then? So let's go here. So this will be minus infinity, right? And I will have plus infinity over here. Let's put 0 over here. Let's say 2 over here. Let's put 4 over here. Okay. And from above, what we see is over here is increase. That's what I get, plus sign. And the plus sign will be indicated by an arrow pointing up. In the third interval, I get a negative value. So this will be a decrease. And I will get myself an arrow pointing down. What about between 0 to 2? I will get a plus sign. So that will be like this, and it will be increase. Last but not least, I get myself a negative sign, I remember. Then this will be a decrease as well. And so while we are here, why don't we assess whether there's repellers, attractors, or semi-stable. This one will be, look at this. This is a repeller, right? Let's say that I have a solution, not a constant solution, but a solution. If I'm here, I will be pushed away from this critical point. If I'm approaching from, I'll be pushed away. So that's why it's called a repeller, right? So let's do this. This becomes an attractor, right? Why? Similar logic. If I'm approaching, I'll be pushed into this particular critical point. If I'm approaching from this side, I will also get myself pushed into this, so it's called the attractor. And also, you can see over here, from the same logic as the first one, this will be the repeller as well. Okay, so I didn't get any semi-stable case over here. I get either repeller or attractor. All right, and what I want to do is I want to go ahead and plot the solution curves, the two-dimensional solution curves. That will be y-axis like this. I'm trying to be consistent with my drawing, so there we go. So, you know, obviously this is x, this is y. So now this is traditional. Okay, so let's plot this over here. This will be my y is equal to 2, right? This is one of the critical points, and I have myself over here, y is equal to 4. This will be my, 4, 2, and 0. So these three lines actually indicate those are my critical points, and they're like walls, right? Okay, let's draw the solution curves. So you can see, let's say that my solution falls into, you know, as we discussed before, we said it P naught. Now I'm going to call it y0, right? So let's say that my solution is y0, and this y0 is less than 0, right? So then I will get myself in this decreasing, so it will have to be like this, all right? If my 0 falls into a point, it doesn't have to be right in the middle. Do you realize that? It's an arbitrary point between 0 and 2. Now I'm bounded above and I'm bounded below, and I'm increasing. So this will be similar to the previous example that I have done. I have to be like this, okay? What about between 2 and 4? Let's say that my y0 falls into this particular solution, y0 falls into this particular interval. Then it says decreasing, and I'm bounding above and below. It will be the reverse of it, so I will have something like this over here, okay? And if y0 is larger than 4, and I have, let's say, arbitrarily at that particular point, it says increase, so I will be asymptotic over here. As my x increase and increase, I will be increasing without bound, all right? And obviously this is a plus infinity all the way over here, right? Just to highlight, this is a negative infinity all the way down there. So this is pretty much is what is happening from what we have covered so far. You can see that, at least in my opinion, this is not very dense. All right, this is fairly manageable in my opinion. All right, but one thing is, as I mentioned, starting from the very next segment, I'm going to solve this equation. So why don't I go ahead and solve this equation and see what happens? All right, and I can show you this is a separable equation. Again, I'll talk about this in the next segment, but I'll give you a flavor of this. Okay, so let's go ahead and rewrite that over here. So I have my dy dx. I don't want to write that way, but I want to write this the y times y minus 2 y minus 4. Okay. So I didn't want to write like that because it's much harder to solve. We will see why in a minute. I wrote this one. I copy pasted that over here. So now what I'm going to do is, it's a separable equation by definition because this is only a function of y. So why don't I move this down here, and why don't I move this dx to up there, right? And take integral of both sides. Yep, that's exactly what I'm going to do. And as you know, if I have critical points, they are 0, 2, and 4. Just want to note that, right? So let me do what I just said. dy divided by y minus 2, y minus 4 will be equal to dx, right? So now I have to take the integral of this equation. Obviously, it will be not that easy to take the integral of this 1 over y times y minus 2 times y minus 4, right? I will do one of the oldest tricks in the book. So I would like you to be cognizant of this. The approach is, I always do this if it's a multiplication. A over y, I don't know what a is, b over y minus 2 plus c over y minus 4, I ran out of space, will be equal to 1 over y minus 2, y minus 4. Do you see that? So what I did was, instead of writing it this way, I want to write them this way, right? And the goal is to find a, b, and c values, right? So you know this from mathematics, how to approach that. Actually, let me go ahead and change the color. It seems a little bit not contrasting well with the background. Okay, so I'm going to multiply this y minus 2 times y minus 4. I'm going to multiply this y times y minus 4. Now multiply this y times y minus 2, and that's sum them up. As you will see, the denominators will be the same, right? So let's go ahead and do that. So I'm going to get myself a y minus 2, y minus 4, plus b times y squared minus 4y, just taking a shortcut, plus c times y squared minus 2y. Okay, divided by, the whole thing is divided by y times y minus 2 times y minus 4 will be equal to, okay, again I run out of space, actually I run out of page as well. I'm going to go to the next page. So it's going to be 1 divided by y minus y2 y minus 4. Do you see that these denominators will cancel each other out? Right, because they are the same, right? So now let me look at the left hand side first, and the right hand side is kind of easy. So let's do this. A, and this is actually the multiplication of this is going to be y squared minus 6y plus 8. You can do this if you want to. Actually, I'll show you. Where is it? Right here, right? See? So I'm just going back instead of going forward from that angle, all right? So let me continue. Plus b y squared minus 4y plus c y squared minus 2y. Now what I want to do is equal to 1 on the right hand side, right? What I want to do is I want to write this way, y squared times, okay, let's see, a plus b plus c. Do you see that? Let me illustrate. A times y squared, b times y squared, c times y squared. I don't see any other. Let's do plus y times, it's going to be minus 6a minus 4b minus 2c. Let me illustrate that. A times minus 6, right? B times minus 4. C times minus 2, right? Plus, now just the numbers. So I'm going to get myself 8a plus, well, that's it, right? There's no constant over here. Is equal to 1. Now, the right hand side, I want to actually, I mean, most of you have seen it, but I want to double check everybody's on the same page. So this, do you see that this is 0 y squared plus 0y plus 1, right? So now I can equate whatever is in front of y squared to be 0. So this is 0, this is 0, this 8a is 1. I'll use that, and you will see that a plus b plus c is equal to 0. You can see everything is a negative here, so I'm going to actually multiply this by negative because the right hand side is 0, and let's divide by 2 as well while I'm there. So it's going to be 3a plus 2b plus c is equal to 0. And the last one says that 8a is equal to 1. So from here, I get myself a is equal to 1/8, right? That's 1. From here, I get myself b plus c is equal to minus 1/8, right? And from here, I will get 2b plus c is equal to minus 3/8, right? I simply plug this a value to here and rewrite this. I'm just saving some time. I don't want to go over it over and over again, all right? So what I will do is I will, let's say that subtract this equation from this, right? So if I subtract them side by side, you will see that the c's will cancel. So I'm simply going ahead and doing this. 2b plus c minus b plus c will be equal to minus 3/8 plus 1/8, because minus and minus becomes plus, right? So you can see c's cancel over here. I get myself b is equal to minus 2/8, which is minus 1/4. And then I can use maybe this equation. I know my b minus 2/8 plus c is equal to minus 1/8. So from here you get myself c is equal to minus 1/8 plus 2/8. So I get myself c is equal to 1/8. So this is what I get. And I go up over here. What was my main goal is to obtain this. And I did obtain this now, right? So let's go ahead and write this. So basically, 1/8 divided by y minus 1/4 divided by y minus 2 plus 1/8 divided by y minus 4 dy is equal to dx, right? So I simply rewrite this equation this way, and then what I'm going to do is I'm going to take the integral of both sides. You can imagine that. So if I take the integral of this side, what I'm going to have, the left hand side, is you do realize this is ln y, right? 1/8 times ln y. So let's write this. 1/8 times ln y minus 1/4 of ln y minus 2, right? Plus 1/8 times ln y minus 4, right? Will be equal to the integral of right hand side will be x plus c. Okay. I'm going to go ahead and multiply both sides of the equation by 8. So I can get ln y minus 2 ln y minus 2 plus ln y minus 4 will be equal to 8x plus 8c, right? You do realize that 8c is still a constant, so I'm going to call it c1, like another constant. You can call it d, right? So if I combine them, so let's make sure I show the details. ln y minus ln y minus 2 square, do you see it? Plus ln y minus 4 will be equal to 8x plus c1. So if I just now combine this, I can combine this way. I recommend that you study this. Y times y minus 4 divided by y minus 2 squared. ln is only defined in the positive, so that's why I have this absolute signs. And ln y plus ln y minus 4 becomes ln y times y minus 4, right? And this is the, again, please study these features of ln logarithms. Divided by y minus 2 squared will be equal to 8x plus c1, and then I proceed with it. I will get myself e to the power of both sides, so I will get y minus 4 divided by y minus 2 squared will be equal to e to the 8x times e to the c1, right? And e to the c1 is still a constant, so I'll call this d, and I will have myself, you can see, y times y minus 4 divided by y minus 2 square is equal to d times e to the power of 8x. Also, one thing to notice here is that, look here, y is equal to 2 is a solution. Oh, that was a long answer, right? Yeah, right there. y is equal to 2 is a solution. But regardless of what I obtain, look at the solution. I cannot obtain y is equal to 2 as a solution here, right? And if you remember our conversations from the previous segments, this means that y is equal to 2 is a singular solution. And this also illustrates that in some cases when I do separation of variables, I lose a solution, right? So this is something to notice. But if this was an exam question, this is what I expect you to present to me as the final answer, all right? So thank you for watching this segment, and I will catch up with you in the next one with separable equations. Thanks.